Can I solve this problem? The block diagram of a control system with a proportional controller is shown below. The block diagram of a control system so tau p is equal to 8, tau m is equal to 1. A unit step change is introduced in the step point. A unit step change is introduced in the set point. In the set point. The value of Kc that provides a critical damped response is. The value of Kc that provides a critical damped response is. So what is the value of Kc that gives critical damped response? What is critical damped response? So first thing is you should write the transfer function, let's say y by x. Then you compare the denominator to tau square s square 2 zeta tau s plus 1. So when we are taking step change in x, u is 0. So first thing is write what is the transfer function y by x. So how do you write y by x? Kc into 1 by 8s plus 1 divided by 1 plus 1 by s plus 1. Kc into s plus 1 by 8s plus 1 into s plus 1 plus kc. Kc into s plus 1 by 8s square plus 9s plus 1 plus kc. This is what is 1 plus kc. So now you have to write in the standard form. Y by x equal to kc into s plus 1 8 by plus 1. Now this you have to compare with the tau square s square. Numerator can be any form, but denominator is important. 2 zeta tau s plus 1. So what is tau square? 8 by 1 plus kc. 2 zeta tau s is 9 by 1 plus kc. For critical damped response, what is zeta? Zeta tau. So what is zeta? 1. Yeah, okay. The numerator will also change by 1 plus kc. Let's substitute tau values here. You will get what is the value of tau kc. So we'll go to next chapter, chapter 5. Cascade control. So there are two controls, cascade control and feed forward control. So today we will complete cascade control and tomorrow we take feed forward control. Somebody is asking to show the previous one. Answer is 1.53. Cascade control. So what is cascade control is basically what is the cascade is controller inside controller. Controller inside the controller. Suppose if you take the CSTR case, let's say this is my CSTR. This is going out. You have a cooling water. So your cooling water is coming in. Cooling water out. This is A in, B out, C out, control. Clear? So at steady state, whatever we have done in the first case, what is the inlet temperature is 35 degrees. What is the outlet temperature is 45 degrees, and you are sending 1 ton per hour. So what is inlet temperature is 40 degrees, outlet temperature is 60 degrees. So in this one, suppose if there is a change in the 40 degrees, your 60 degrees rises, and then accordingly it will send the more cooling water. So what happens to the circuit is the cooling water which is coming to the, let's say, cooling tower, and then this 35 degrees. So this is the cooling tower. So what is the principle of cooling tower? It operates on the principle of air temperature. So it sends air, and based on the air temperature, the cooling water temperature changes. So air temperature A temperature, let's say, controls the cooling water temperature, that is 35 degrees. What happens to the system? Suppose instead of 35 degrees, if you send 40 degrees cooling water, but the outlet has to be fixed because outlet is 50 degrees, because the cooling tower is designed for the maximum inlet of 45 degrees. Suppose if the cooling water temperature changes, let's say 35 to 40 degrees, then what happens? What happens if I cooling water temperature changes? Suppose if cooling water temperature moves to 40 degrees, 40 degrees, then what happens? Then what happens to your 60 degrees? Your 60 degrees will start to rise because you are not removing the entire heat. No, the 60 degrees will not rise. Then what does the controller will do? Controller will start sending the more cooling water. Then it will come back to 60 degrees. So basically what you should understand here is air temperature changes from season to season, or let's say daily also. It changes the cooling water temperature, which is also affects my process. This is also affects my process. This is the problem. So air temperature changes, which is changing my cooling temperature, which is changing my process temperature, affects my process. So how to eliminate this disturbance? How to eliminate this disturbance? So how to eliminate this disturbance is, just come back to here. So we will introduce a concept of cascade control. So what do you do here is, you will measure the cooling water temperature. You will measure the cooling water temperature. This is cooling water. Then you have a controller C2. This is C1. So the main controller, now you will slightly change the path. Now you will send the set point to the secondary controller. This receives the measurement from the cooling water. Then accordingly, this controller operates the cooling water flow rate. So what does it happen is, suppose if 35 degrees is there, I need 1 ton per hour. If 40 degrees is there, I need 2 tons per hour, because the delta T now is 5 degrees. Earlier it is 10 degrees. So now when so the primary controller, so the C1 is called as the main controller or primary controller. C2 is called as the secondary controller. So the primary controller, which gives the set point or gives the cooling water flow rate to C2. C2 now measures the plant temperature of cooling water. Suppose if the plant cooling water temperature is 35, so it doesn't do anything, it just passes the signal of C1. Suppose if C2 detects that the plant temperature of cooling water is 40 degrees, then what happens is, it changes the flow rate of cooling water from 1 ton per hour power to 2 tons per hour. So this is, you are introducing another controller so that you to eliminate the effect of disturbances on the process. So does everybody understand the concept of cascade control? Just spend some time and understand. I'm going to give 5 minutes. Just digest the concept. I'll explain one more time, but please try to understand. Just spend some more time and write a lot of theory on cascade. So what is cascade control is? So basically the cooling water temperature changes because the cooling water, how do you cool cooling water is, you are cooling hot cooling water comes, that hot cooling water goes to cooling tower. That cooling tower outlet will be is something which is going into my CSTR. So since air temperature changes, the cooling water temperature is also changes. So that means always you may not get a right cooling water. Sometimes it may be 31, 32, 33, 34, something like that. So if it is 35, exactly we need to remove, like the first chapter we have discussed, 100 kilojoules of heat is uh, liberated. Out of that, 60 joules is internally consumed and 40 joules, and 60 joules has to be removed. For that 60 joules, we need 1 ton per hour of cooling water flow rate. But that 1 ton depends upon what is inlet temperature, outlet temperature, because MCP delta T is equal to heat has to be removed 60 kilojoules per hour. Now, if the inlet temperature is 35, outlet temperature is 45, then 1 ton per hour. Suppose inlet temperature is 40, outlet temperature cannot go to 50 because the cooling water can take maximum 45 degrees. Clear? Now, if the cooling water temperature is 40 degrees, I need the 2 tons per hour, but you are sending only 1 ton per hour. Then what happens? Your process upsets. This upset is because of cooling water, not because of your 40 degrees. Clear? What do I consider disturbance to my system is this 40 degrees I consider as a disturbance. So then my 60 degrees changes and then we'll come back to 60 degrees. Now, how to eliminate this disturbance is you introduce the concept of secondary control. That is, you measure the cooling water. That measurement of the cooling water will go to secondary controller. That secondary controller will receive the set point from the first controller. So it compares the first controller set point depends upon the cooling, because you can get one question that why can't we give the cooling water temperature to the C1 itself, because this is not possible, because every controller will have a one set point, one measurement, so that will generate error which is R minus M. So that is why, because you are not buying any controller, no, what is the extra that you are getting is one data cable from the plant. So that is measurement of the cooling water temperature and the cooling water temperature measurement. So you will measure the cooling water temperature. Suppose if the cooling water temperature is 40 degrees, you instantly change it to 2 tons per hour. Did everybody understand what is a cascade control? Any doubts? nodes. If cooling water temperature increases, you need more. You don't need more heat, but you need more cooling water to remove the same amount of heat. Can you translate this into a control diagram? How the controller will work is, suppose if you receive a cooling water of 40 degrees, this C1 will send 1 ton per hour, but this C2 changes to 2 tons per hour. Can you draw control diagram? What is the control diagram? What is the control diagram? So can you draw the control diagram? So first your CSTR output is temperature of CSTR. Now what is input to the temperature of CSTR is load, cooling water. These two will act on the CSTR. You are measuring the temperature of the CSTR measurement. Then controller. So let's say what is main controller C1. C1 gives to, let's say, valve. So valve output is cooling water flow rate. But what happens is this cooling water, you are measuring the temperature again. So the temperature of cooling water, which goes as a, now here there is small change. So here you have the control valve, and then here you have the C2. So the temperature of the cooling water will go as input here. So plus minus. So this is the control loop inside the loop. Loop inside loop is what is cascade control. If you get any loops inside loops, it is cascade control. So everybody understood why we use this controller is to eliminate the cooling water setting. So here, if you try to see how many measurements, does everybody understand? So I'm going a little bit on slow because she'll understand the cascade control and then appreciate the entire thing. So how many measurements you have here? If we start writing the questions, how many measurements? How many measurements? How many measurements you have? 2. So what are the 2? Temperature of CSTR, temperature of cooling water flow rate. Temperature of CSTR, temperature of cooling water. So how many controllers you have? Controllers. One is C1, C2. This temperature of CSTR is called as primary measurements. Temperature of cooling water is secondary measurement. So what is C1? Primary controller. R master controller. C2 is secondary controller or slave controller. Secondary controller or slave controller. How many manipulated variables you have? How many manipulated variables? How many manipulated variables? How many manipulated variables you have? You have only one, which is cooling water flow rate is manipulated variables. So basically, how do you this concept is multiple measurements plus single manipulated variable. Multiple measurements plus single manipulated variable is what you call it as cascade control. Now here if we see this control, which one should be faster here? Who is opening the control valve? C2. Who is opening the control valve? C1 or C2? C2. So here the innermost slave should always be faster. So this is a faster controller. So if you have, this is faster. The one which is finally is there should be faster because that is the one which is opening the control valve. Suppose if you have 1, 2, 3, 4 in slaves, the last controller should be fast. So this is what is Cascade controller. So any doubts you have? I think we will close it here. Tomorrow we'll discuss the feed forward controller. So do you have any doubts on the Cascade controller? So basically controller inside the controller is called as the Cascade controller. This will be little dry. You might be little, this chapter itself is, you can't increase the cooling water outlet because the tower is designed for 45 degrees.